the degree of the polynomial will tell us two things. Does anybody remember these two things? I know that's a very vague question. I'm just seeing what you remember. The degree of your polynomial tells you two things. Anybody?
End behavior?
Yes, in behavior, which is what we just talked about, because if it's even up, odd, down, but I'm talking about two different things, like the actual number of the degree. There's two things that tells us besides in behavior.
How many times it curves?
No, y'all just said the same thing. Good, extra credit. That is one thing. It tells you the maximum number of turning points, okay? So let me just show you before we write that down, because I'm making sure we have seen this before. What kind of function is this? Quadratic. Good, which means it's x squared. How many turning points does every quadratic have? One turning point. It goes down and then it'll come back up, or it goes up and then it'll come back down, right? All right. What kind of function is this? And some of y'all are gonna be like, what the freak is that? Yeah, it is cubed. So this is just a cubic function where we have stretched it and we've shifted it, which is why it goes up, down, and then back up. So this is x cubed. Good job. How many turning points does the x cubed function have? Good. Are we noticing a pattern? I hope. I'll do one more. Nope, not answering it. Y'all are more important than that. What kind of function is this?
X to the fourth.
A quartic function, x to the fourth. Good. Kind of looks like a butt. How many humps does it have? A saggy old lady butt. Good. What's the pattern? What are we noticing? It's the degree minus 1. If it is squared, it is quadratic. It has one turning point. If it is cubed, it has 2. If it is raised to the fourth, it has 3. So the first thing the degree will tell you is the maximum number of turning points. Good job, KJ and Kendall. I'm sorry, y'all can't see that. There we go. There is something else it tells us.
Goes through like x and how it goes through x.
Good. Okay. I want to show you guys what she just said. I'm gonna have to use different colors. All right. Look at this quadratic. Not this color. Let's use this color. How many x-intercepts does this have? Okay. Does it have to have 2? No, because if we shift it up, it might only have 1, or if we shift it all the way up, then it has none. But maximum number of roots is 2. So look at the cubic function. What's the maximum number of roots? 3. Look at your quartic function. What's the maximum number of roots? 4. So it will also tell you the maximum number of roots / x-intercepts. Remember from math 2, those mean the same thing. So just remember the maximum number of turning points is always the degree minus 1. The maximum number of roots is just the degree. Is this new or have we seen this before? Okay, good. Good, good. People at home, are y'all okay?
Mm-hmm.
I heard a okay. All right, so the only other thing, and then I'm just going to give you 2 examples to try, and then we're moving on to rational functions because I feel like y'all are good with this. So the only other thing we need to review is how to find intercepts. All right. What's one way to find intercepts? Not even trying to be funny. What's the fastest way to find intercepts? Yeah, look in Desmos or look in a calculator, right? You guys know how to do that. How do you find intercepts by hand? So let's start out with a y-intercept. How do I find a y-intercept? Because we just did that last unit.
You plug 0 in for x.
Good. To find a y-intercept, set x equal to 0 in the function. And then for polynomial functions, to find an x-intercept, what can we do?
Set y equal to 0.
Okay, and do what?
Solve.
By. Good, and solve by factoring. Beautiful. Now, I'm going to be 100% honest with y'all. I feel like I should not have to re-show you solve by factoring. I feel like we should be okay with that. What I'm more worried about is you seeing a graph. Like if I give you a long equation, you should not have to go type that entire equation in Desmos just to see the max number of roots and the max number of turning points, okay? So can we do a couple of examples? Y'all don't even have to write them down unless you want to, and you're just gonna tell me max number of roots, max number of turning points. Does that sound good? All right. You wanna write them down? You totally can. Do not have to. I'll leave it up to y'all because this is really not the bulk of the lesson today. All right, so I just need you to tell me the maximum number of roots and the maximum number of turning points. How many do we feel like we need? 2? Okay, great. Let's do. So let everybody look at it first. No one blurred anything out. You can write it down or you can just look at it. It really does not matter to me. I feel like a lot of us have seen this. All right, maximum number of turning points. Not everyone at once. What's the maximum number of turning points? Good. 4. What is the degree of this polynomial function? Biggest exponent is the degree. We remember that from Math 1, right? The degree is 5. I just didn't put it in standard form because I was looking to see who would pay attention. So the max number of turning points is 4. What's the max number of roots?
5.
Good. Questions on that one? Easy or hard? We're okay? All right. Next one. Let's do. The max number of turning points. Good, 9 because the degree is 10. Max number of roots then would be 10. Now, what if I ask you about end behavior? Should you have to graph these? No. What can you look at? 2 things you can look at. What's one? We'll start with this one because it's on this one. The reflection, do you guys see how the negative 3x to the 10th is reflected? Okay. And then the degree is what? Even or odd? Even, which means they open the same way. If it's reflected, they're both going to open down. So watch, as x approaches negative infinity, the y will open down, aka negative infinity, right? And then as x approaches positive infinity, the y is still going to open down. So y will approach negative infinity. That's the kind of questions you might see on the pre-cal exam. Please don't waste your time going and graphing that. Look at your sign and your degree really quick and move on, okay? Because problems like on your test yesterday is what apparently y'all are going to need the time for. Are we okay? Okay, let's look at the first one. Odd and positive. So if it is odd, it is supposed to increase. And since we didn't reflect it, it is still going to increase, right? It's going to look something, if it's to the 5th root, that is ugly. No one make fun of me. It's going to look something like that, okay? So as x approaches negative infinity, the graph is going down, which means y approaches negative infinity. Then as x approaches positive infinity, y approaches, you guys learned this, right? Oh my God, beautiful. Right. Do I need to do any more examples? I'm not trying to be funny. Like, does anybody need to see one where I just give you the graph and you find stuff? I think we might need to do that. Let's do that and then we'll move on. KJ, are you bored? All right. We'll do one example right here, and then we are going to move on to rational functions because that's where the fun stuff happens. And I do want y'all to try this without me, and then I will go over it. But I think a lot of you can do this without me, hopefully. So every year on the pre-cal exam, there's always one of these, and I have kids miss it, and it makes me really sad because we learned this before pre-cal. Goes down to. Oh, I'm sorry, y'all can't see that. There we go. Right, so from this graph, I want you guys to find the domain, the range, intervals of increase, and intervals of decrease. And end behavior. How much time do we think we need? Like 2 minutes? Okay, 2 minutes, just try it. See how much you remember, see what you know. Yes, interval of increase going up and interval of decrease where it's going down. Sorry, you know I like to abbreviate. See what you remember. You can ask me questions. You can ask somebody around you questions. People online, y'all can ask me stuff. Just want to see what we remember from Math 3. All right, I think we should be about done. Yes, no? Or ignore me? Yes? Okay, cool. All right, what's the domain of this green graph? Perfect. This arrow goes to the left forever. This one goes to the right forever. So it is all real numbers, negative infinity to infinity. All right, I love y'all, but some of us are still missing range. I don't understand it. What's the range of this function? The smallest y to the biggest y.
Negative infinity to positive infinity.
Beautiful. Because this will continue to go up, this will continue to go up. Let's just review. This has nothing to do with this function, so nobody freak out on me. What if it stopped at these 2 points and there weren't arrows? What would be the range? -2? -2 to 8. Beautiful. We're okay with looking at that. Okay, because once we get to conics, they do not always go to infinity. So we need to be okay with that. All right, where is this graph increasing at? Yes. Good. Extra credit. Sorry, you looked scared. Why do you always look scared when I like point at you? I'm not a scary lady. It's increasing from -2 to 1. Remember to use the x values because I'm asking you, where is it increasing? When is it increasing? So name it by x. It's not -2 to 8. It's -2 to 1. Very good job. Extra credit. Yes. All right, where's this graph decreasing, children? Good. So on this side, it goes down till it hits -2. And then up here, it starts going down as well, right? So Drake said negative infinity to -2. And then it picks back up, decreasing from 1 to infinity. Very good. All right, end behavior. I don't want you to tell me what it is. I want us to talk about the function first. Are the ends going in the same direction or opposite directions? Opposite, which means it is what kind of polynomial? Odd, good. And then it's going up on the left side and down on the right side. So what did we do to this odd polynomial function? We reflected it. Does everybody notice that? Okay, so now that you see those things, what's my end behavior? When x goes to negative infinity, what's the left side doing? So y goes to infinity, good. And then as x approaches positive infinity, what are the y's doing? going down, so that would be y approaches negative infinity. A lot of y'all are still struggling with in behavior. Like, didn't get it right on the first test, still missing it on the second test. You need to come to office hours. I can give you extra examples. Are y'all okay with this? Okay, most important thing, make sure you are listening. Do you see any holes or any asymptotes? Why not? Okay, it does look like an x cubed function, and we already established that it would be negative because we flipped it. Are there any restrictions on this function? Is there any number that x cannot be? No, because there's no what? Okay, there is a y. It should say y equals. Thank you for clarifying, because there's no what. When do we have restrictions on our domain?
When it's a fraction.
Good, when x is in the denominator, because the denominator cannot be 0, that makes it undefined, right? There's other ones too. Can you take the square root of a negative? Nope, so that has a restriction, right? There's no restrictions though if I just tell you negative x cubed, none. If I tell you x to the 5th plus 3x to the 4th minus 2x cubed plus 2x minus 1, there's no restrictions. You can put any number in for x, right? So the biggest thing I need you to know, and I'm going to get artsy, is that polynomial, did I spell that right? Continuous. I did. Okay, I got scared for a second. Polynomial functions are continuous. The domain will always be negative infinity to infinity. There are no restrictions. They go on forever. Why do you think I am stressing that with you? What are we about to talk about? What's the notes title for today?
Rational functions.
There we go, rational functions. Kendall, you already told us rational functions means it's a fraction, right? Because ratio. AKA, there's going to be some restrictions. Rational functions are not continuous. Are y'all good with polynomial functions? All right, let's go to rational. My notes today look beautiful like Natalie's and Prodnia's. What's wrong? Oh no. All right. What color do I want to use? Let's do this one. All right, let's talk about good old rational functions. As a teacher, I love these because there's lots you can do with them. This pen is dying. All right, the very first characteristic I want you to know, we literally just talked about, these are not going to be continuous. So since they are not continuous, what does that mean we'll have on these graphs? Asymptotes, something else. What else? I feel like I got to draw everything out for y'all today. Y'all acting like it's a Monday. Y'all don't even have to come to school on Mondays even anymore. Lucky duckies. What is that thing?
Holes.
A hole? Have y'all never seen a hole? Y'all did piecewise functions, right? Where you could have an open circle or a closed circle? Oh dear God, if you didn't do piecewise functions, then we're gonna have to throw that in somewhere.
I thought they had a more technical term.
Oh no, it's just called a hole.
Oh, okay.
Never seen a hole? All right. Well, a piecewise can look like this, and then I'm going to get back on topic because piecewise has nothing to do with these. But piecewise functions are the ones that look like this. They have different pieces. That's why they're called piecewise. Like you'll do x plus 2 for when x is less than 5. And then you'll do x squared minus 1 for when x is between 5 and 2. And then you can do 2x cubed for when x is greater than or equal to 2. Y'all have never seen that. Okay, so we have. Okay, y'all freaked me out for a second. So then when you end up graphing it, and this isn't going to be right, so no one judge me. I'm just like showing you what it could look like, okay? It ends up looking like this in places. There's holes.
Oh, yeah.
Okay, same thing with rational functions. There are holes. Ooh, I'm nervous. All right. Okay, we're going to get it. Asymptotes and holes are present. Because there will be values where f of x is undefined. Rational functions cannot be continuous, meaning there will be asymptotes or holes or both in some situations, because there are values where the function is not defined, it's undefined. So if you're like, what the heck, just remember, this is just an example up here. This is a rational function. It's a ratio, and there are x's in the top and bottom, right? So if you have something like this, we know the denominator can't be 0. So you would have to set the denominator equal to 0, solve, figure out where your holes and asymptotes are. Does that make sense? None of these rational functions can be continuous. They won't be, because a denominator can never be 0. This cannot equal 0. You may want to write that. If you know it, then you do you. But that is the biggest thing. They will not be continuous. I'm using Halloween colors on this page. So since they're not continuous, Prodnia laughed at me. Since they're not continuous, what does that mean about our domain and range? I'm quizzing you. I'm saying how much we can think. There won't be infinities, not just negative infinity to infinity. It's not going to be all real numbers, right? Which means chances are we're going to have multiple intervals, right? If there's holes or asymptotes, then we're going to have to go like from negative infinity to 2, then pick it back up at 2, kind of what we did in the first unit, okay? Domain and range may be broken up and have multiple intervals. Some of y'all are about to be very happy. That's the only characteristic you need to know for rational functions. All I need you to know is there's going to be some asymptotes and holes. We're going to talk in a second about how you find the asymptotes and holes. But are you guys okay with that characteristic? They will not be continuous because somewhere it's going to be undefined. Yes, no, yes, no? Okay. All right, so let's do 2 examples where we're just looking at the graphs, and then I have to show you couple more things, okay? But then we'll be done, and you should have homework time. So example 1, we're gonna find the features by graphing, and you can absolutely look at the graph in Desmos. That is what I'm gonna do. Sound good? So the first function we'll look at, let's do, oh, I didn't mean to do that, but okay. 3x minus 1 over, and then the second one, let's do that one from the top. People at home, let me know when you have these so I can switch to Desmos.
Got it.
Got it? Are we good, people at home?
Yes.
Y'all are good? Y'all got these written down? I'm gonna flip the
I
desk.
need like another minute.
Okay. I'm about to pull it back up. Here you go.
I'm good.
You're good? Can you see it, Ross? Yep. All right. Share screen, share to Desmos. All right, children, so check it out. If they just give you a rational function and they ask you to find the feature, so y equals 3x minus 1 divided by, oh no. All right, Desmos. Turd. There we go. Over 2 minus 5x. Check out the cool graph. Does everybody see the cool graph? Yay, so cool. So exciting, right? Could you find the domain and range? Man, I hope so. Why is no one saying yes? Can we find the domain and range? Yes. Okay, great.
Yes.
Thank you, awesome. Can we find increasing, decreasing? Sure, so I'm just gonna talk about it. We'll write it in a second. The domain looks like it goes all the way to negative infinity, right? Because this keeps going. Does everybody agree? And then what does it look like it's stopping at right here?
1.
Not. It's somewhere between 0 and 1. It's not a half, because a half would be right here. And if you look down, that red line is on a half. So this gets me exactly into what we're about to talk about, okay? It looks like it's between 0 and 1. Can you tell exactly? If it was multiple choice, you could probably guess and pick the right one. But it's not multiple choice. Brody's like, of course it's not. Why would it be? Okay, then whatever number this is, it picks back up and goes to infinity. Does everybody agree? Okay, so that would be the domain. Then the range starts, it looks like it goes all the way down. So it starts at negative infinity. And same thing, it looks like it comes to some number. It's a different number this time though, but between 0 and negative 1, right? And then whatever that number is, it'll pick up back up and go to infinity. So I'm gonna draw. No one make fun of my drawing because it's actually very hard to click and drag on this ish. Oh my God. All right. Y'all can see this blue line, right? Looks like there's an asymptote there, and it also looks like there's an asymptote. Ew, ugly. That's okay. Here. Does everybody agree with that? Yes, no? People at home?
Yes.
Okay. If all it says is given this equation, are there vertical and horizontal asymptotes? All you have to do is go graph it and look. Yeah, it looks like there are, right? But if it's asking you for the specific domain and range intervals, the specific asymptotes, can we see that from the graph? No. Which is why as a teacher, I love these. Because the graph won't do everything for you. You have to actually think about these. Okay? In Math 3, I think you got to just look at the graph a lot and guesstimate with multiple choice. Welcome to Honors Pre-Calculus. No guesstimating. We're going to find the actual numbers, okay? Yes. All right, end behavior. As x approaches negative infinity, that y is going to get closer and closer to this asymptote, right? Okay. As x approaches positive infinity, it'll get closer and closer to this asymptote. Do we agree? So we just need to find, the main thing we need to find is these asymptotes so we know what numbers those are, right? Everybody agrees? Okay. Let's look at our other example. And if it's going to bother a lot of you, these can be our two examples we do when we actually find the asymptotes. Since y'all wrote it out. Okay, why are you mad? There we go. All right, x squared plus 2x minus 3 divided by x squared minus 5x plus 6. Looks crazy, right? Let me see if I can see. Okay, so it looks like we've got an asymptote in between these two. Does everybody agree? Okay. Can you see if there are any holes? Anybody, can anybody see? I'll zoom in really far. Does Desmos give you any holes? And before you're like, well, dang, Desmos sucks, I'm going to use my TI-84. It's even harder to see in the TI-84. I would definitely use Desmos. So the issue with rational functions for you guys, y'all think it's an issue. I love these. You can't see asymptotes and holes from the graph. Meaning we're going to have to find them algebraically. Yay. Oswald is thrilled. All right. So we are going to come back to these examples. I'm actually going to start with this one. Let me just flip to my notebook for y'all, because this is a great one to do. I'm really hoping that we did learn this in Math 3, but we're going to make a little note real quick right here. In Desmos or the calculator, make sure you're writing this. So in Desmos or the calculator, you can't usually see the exact values for asymptotes / holes. Meaning you guys just told me we're going to have to find them algebraically, right? Yes. All right, and this is where we can do it one of two ways. I want you guys to tell me what would work for y'all, okay? So you as a learner, which one would be better? Would you rather me give you all the steps first and then we do an example? Or would you rather do an example and then put the steps to the side as we go? Anybody at home have a preference? They're saying do an example and do the steps as we go so y'all can see it in action.
Yeah.
Yes.
Yeah,
Good? Okay, cool. Let's do it. So are y'all good if I use this same example? Because this is a great one to do. Great. Everybody's good? All right, so we're still going to go with example B. The first thing you are going to do is factor what you can factor, numerator, denominator. Which ones can I factor here? Both. Beautiful. So we're going to factor the numerator and factor the denominator. So step 1, factor numerator and or denominator. Whichever ones you can factor, you're going to factor. We're doing that so we can simplify it, okay? Y'all let me know when y'all are ready for me to move it along. Am I good to start factoring? Okay, factors of 3 that subtract to give me 2 are what? 3 and 1. Which one needs to be positive and which one needs to be negative? Which one? 3 needs to be positive, good. 1 needs to be good. Is everybody okay with that? All right. In the denominator, factors of 6 that add to give me 5. It is not 6 and 1. So many of y'all missed this on the test because you factor at 6 and 1. What are your factors of 6 that add to give you 5? Good. 3 and 2. And they both need to be what since we're adding? They both need to be negative. Very good. Are we okay with that part? Okay. Here's where the cool stuff happens. If anything cancels out, then you have a hole at that point. Did everybody hear me say that? If anything cancels, you have a hole. So let's write that down. If any factors cancel out, then you have a hole. All right, do any of these factors cancel out? Do you have anything in the top and the bottom that's the exact same that I can eliminate? No,
No.
so do we have a hole?
No,
No.
ma'am.
Perfect. So now we should remember this from unit 1. What can X not be? No, the denominator can't be 0. So what can X not be? Good. The denominator can't be 0, which means X cannot be 3 because X minus 3 equals 0. X would be 3, right? Can't be 3. And X can't be 2. Guess what? There's your 2 vertical asymptotes. Are we okay with that? All right, y'all got to talk to me. Ah! Yes, so your denominator we learned in unit 1 can't be 0. So this means X minus 3 cannot be 0 and X minus 2 cannot be 0. So we just solved it in our head. If you get X by itself, it can't be 3 and it can't be 2. It's always the denominator because guys, what happens if the numerator is 0? Does that matter? Good. Can somebody say it with confidence besides Ann? Does it matter if the numerator of a fraction is 0? No, that just means it's 0. That's not undefined. It's undefined when the denominator's 0, okay? So step 3, you're gonna set your denominator factors equal to 0 and solve. This gives you your vertical asymptotes. You will be able to factor. I won't give you one that won't factor. That would be cruel. You'll do that in calculus if you take calculus. There are some where you have to do quadratic formula or completing the square to find the asymptotes. But that's not pre-cal. Pre-cal, you should be able to factor them. Are we okay with how to find vertical asymptotes? Because we did that in units 1 and 2. We have seen that before, right? Okay, so the last thing you have to check for, we check for holes, vertical asymptotes, or horizontal asymptotes. Hopefully, we remember this from Math 3. I hope, I don't know. I'm just gonna write it. So find your horizontal asymptotes. My ladybug keeps getting in the way. You're going to check the degrees in standard form. Of the numerator and denominator. And then there are 3 things that can happen. And I will have time to do one more just example after this, okay? But then I want y'all to try your homework. All right. It says in standard form, right? So I'm not worried about my factored form. I'm going to bring down the problem we started with, which was x squared plus 2x minus 3 and x squared minus 5x plus 6. All right, look at the degree of the numerator and denominator. What do you guys notice? They're the same. Good. Does anybody remember from Math 3 what the horizontal asymptote is if the degrees are the same?
1.
Are equal. Not always 1. That says degrees are equal. Are y'all okay with me abbreviating? Yeah. If they are equal, whoever said 1, why did you say 1?
I was thinking 1 because 2 divided by 2 is 1, but when you're dealing with exponents, 2 divided, or the x2 divided by x squared is x to the 0, so that would be 1.
It's still 1, but look, this is what you're really going to look at. Look at your coefficients. What's the coefficient with this x squared? Not everyone at once. 1. If there's no coefficient, it's an understood 1, right? Okay, I'm going to take a second because y'all, I feel like y'all aren't with me. I'm only going to do one more because this is Math 3. So make sure you're paying attention. All right. What's the coefficient of the bottom one? 1. What is 1 divided by 1? So for this one, the horizontal asymptote is 1, but it's because we look at the coefficients if the degrees are the same. Because like Kendall said, these would cancel out. Okay. So our horizontal asymptote is going to be y equals 1. That is our horizontal asymptote for this one. And then our vertical ones were x equals 3 and x equals 2. So if the degrees are equal, you do the numerator coefficient. I'm going to abbreviate over the denominator coefficient. And that will give you your horizontal asymptote. And if it is horizontal, it is y equals. Some of y'all are still missing that on the test too, okay? Numerator coefficient over denominator coefficient. All right, what if the degrees aren't equal? Give me one option. If the degrees aren't equal, do you want the big one, the top one to be bigger or the bottom to be bigger? Okay, let's talk about the top. If the numerator degree is bigger, anybody want to guess what happens, or y'all are at this point just like, no, just tell me? Okay, if the numerator degree is bigger, you don't have a horizontal asymptote. No horizontal asymptote. Yay. That's our favorite. Doesn't happen often, but that is the best case scenario. I'm guessing y'all have not seen this before. That makes me sad. Okay. It's not your fault. All right. So then the other option is that the denominator's degree is bigger, right? And this is an easy one too. If the denominator's degree is bigger, then the asymptote is just going to be at y equals 0. So really the only one you have to do work for is if they are the same. I feel like we need another example. Yes? No? Yes. It makes no sense to you? Oh, I thought you said it makes no sense to you. I can explain to you why this happens if you want me to. She's like, no, please no. Don't do it. All right, we're okay? Okay. I'm going to flip. I'm going to do one more example, and then I will give you some homework time. The good news is your homework is in Delta Math, and we know that Delta Math has the show example button. So if you're struggling, you can click that, and it'll walk you through how to do it. All right, example 2. Let's do that one. That's a good one. Oh, 21. Don't put 1. It's 21. Reading is hard. Over 2x squared plus 19x plus 45. And I want you to find all asymptotes or wholes. Now, you can actually start with the horizontal asymptotes if you want, because isn't this in standard form? Okay, how do I check for my horizontal asymptotes? What do I look at? The degree, beautiful. So the numerator has a degree of 1. The denominator has a degree of 2. So which one's bigger? The denominator. If the denominator is bigger, who remembers what our horizontal asymptote is? Very good. Horizontal asymptote is y equals 0 because the denominator's degree was larger. That's it. That's all there is to horizontal asymptotes. You look at the degree of the numerator denominator. If they're the same, it'll be the coefficients. If they are different, it depends. If the top one's bigger, no asymptote. Bottom one's bigger, the asymptote is 0. If you want to come to office hours, I can show you why that is to help you remember. You all, the degree, wherever the biggest exponent is. These are just in standard form, so the degree is in the front. Okay? All right, so now I need to find any wholes or vertical asymptotes. So what do I do? Factor it, good. How do we factor the numerator?
Take out 3.
Yes, what's that called? 3 is the what? Good, KJ. Greatest common factor. So take out a 3. Do y'all agree we're left with x plus 7? Okay. And so now we just have to factor the denominator, right? Okay. No one get mad at me. Look at me. How many of you learned slide and divide? If you haven't already learned slide and divide. Slide and divide doesn't work in pre-cal, which is why me and her always used to fight about she shouldn't even teach it because it doesn't work, okay? You are going to have to factor by guess and check in pre-calculus. You don't have enough time to go do slide and divide. You also cannot do slide and divide when we start factoring sine, cosine, and tangents. And all of you looked terrified. Don't crap yourself. It's okay. Okay? We're not going to do slide and divide. So let me show you how to do guess and check factoring in case you've never seen it before. What are my factors of 2x squared? What two things multiply to give me 2x squared?
2x and x.
Perfect. Ross, you've seen this because I taught y'all guess and check. 2x and x. Now, what are my smallest factors of 45?
5 and 9.
5 and 9. So look at me. Usually, it is the smallest factors. Usually, like I would say 90% of the time. So we need to plug in 5 and 9 so that when we FOIL, we end up with 19 in the middle. So can anybody look at this and see where the 5 and 9 should go?
Yes.
Okay, good, Ross. Good. Look at you. The 9 needs to go here. The 5 needs to go here because when you FOIL, check this out. 2 times 5 is 10, right? And 9 times 1 is 9. So 10 and 9 do make 19. It's easier than slide and divide. Slide and divide have like 7 freaking steps. Too much. You're going to do it just like this. And I'm making you do it this way now because when we get to factoring trig, you can't do slide and divide because it's words. It's not numbers. It's like cosine squared plus cosine x sine of x minus sine squared x. And it'll say factor. And y'all are like, slide and divide won't work. Okay? Are y'all okay with how we got these two factors? Okay. Does anything cancel? So do we have a whole? No. If it does cancel, that is where you have a whole. So let me just talk about it. If both of these said x plus 7 and you canceled them, then at x plus 7 equals 0, there would be a whole, which means the whole will be where? At x equals what? Good. And then to find the y value, you could just go put -7 in, right? Are y'all okay with that? Okay. A lot of times there aren't holes though. If there's no holes, what's the only thing else I have to check for? Vertical asymptotes. Very good. So how do I find my vertical asymptotes?
Set the factors equal to 0.
Good. 2x plus 9 equals 0, and then x plus 5 equals 0. So what is my first vertical asymptote?
X equals -5.
Okay, this one, sure. X equals -5. Then I think I heard somebody say this one. -9/2, good, which is just -4.5, right? But these are your two vertical asymptotes.